So here's the function drawn for you. This is an x squared minus 2x minus 3. U-shaped graph, would you agree? And there it is, U-shaped graph, okay? And you want to, and the question is draw dy dx. So on the same axis, draw dy dx. So if I was to differentiate this, right? If I was to differentiate that, what would I get? 2x minus 1. What shape would that be? That's if I was to draw that, what is that? Sorry, it's divide. Sorry, that was a test. You're great to pass my test, Emily. I don't know what the rest of them are doing. Right, okay. Right, are we okay? So that, what shape is that? When you draw that, what is that? It's a line. So when you differentiate a smiley face, you get a line. Would you agree? Right, and at the turning point, dy dx equals 0, yeah? So when we're drawing dy dx, right, at the turning point, dy dx equals 0, so there's the turning point. So at the turning point, the line that you're going to draw is 0, right, okay? So look at that turning point, right, the line goes to 0, right, okay? And it's a sketch. Now, you're only sketching, right? We know it's a line. Has it got a positive or negative slope? Slope of that? Positive or negative? Positive. So it's a line going up, so there you go. Right? Now, you don't know whereabouts it is, right, but it's a sketch. So that's all you need. Is that all right? Okay? And if you think about it, right, coming down here, the slope of this line, the slope of the tangents at all points from here to here are negative. So that means dy dx is negative, means it's below the x-axis. And up here, all the slopes of the tangent will be positive. So that means dy dx is positive, which means dy dx is above the x-axis. So that's just another way of telling you how right you are. Okay? Okay, have we got it? So when you differentiate a curve, you get a line, right? Okay, at the turning point, the line will cross the x-axis because dy dx equals 0, right? And it'll be a positive slope because the x squared term is positive. Whereas, if I had a, right, negative one, you needn't draw this one down now because I'm not drawing it out accurately. But you know, if you had a sad face, right, when you, that would mean it was a minus x squared term, wouldn't it? When you differentiate, you get minus 2x or whatever, okay? So it'll be a negative slope. So at the turning points across the x-axis, it's a negative slope. Now, you don't know where that line is, right? Is it steep? Is it not steep? Doesn't matter, it's a sketch. So all you need is here it's crossing the x-axis and it's a negative slope, right? Is that okay? Are we okay with that? Right, okay, if we had a cubic equation, right, okay, so if we had a cubic equation where, so I didn't put any numbers, I just said it's something x squared, x cubed, plus something x squared, plus something x plus a number, okay, so, and all that matters is, right, that the number in front of the x cubed is positive. So a quick sketch of that graph, right, I don't know, is I just drew a graph and threw in a few points. So a sketch of that graph, it'll look like this. It's a positive A, so that means it finishes on a high, right? If I was to differentiate, I'm going to get what? What kind of, if I differentiate a cubic equation, what do I get? Quadratic, don't you? You get an x squared term, right? The highest power of x will be x squared, right? Would you agree? So it's either going to be a smiley face or a sad face. If that's positive to start with, it's going to be positive to finish with, isn't it? So it's going to be a smiley face. Would you agree? So at the turning points, right, okay, it's going to cross the x-axis because dy dx equals 0 at the x-axis, or dy dx equals 0 at the turning points. Agreed? Right? And you already know it's going to be a smiley face. So now you don't know how deep it's going to go, but it's a sketch, so that's all you need. Is that all right? So it crosses the x-axis at the turning points, and it's a smiley face. Okay, this one, same thing, a cubic equation, right? If you differentiate it, you get a quadratic, won't you? You get x squared in it, right? The highest power of x will be x squared. So it'll either be a smiley face or a sad face, agreed? Right, when you're drawing dy dx on the same diagram, it's going to be a sad face or a smiley face, right? If a was negative, what's this one going to be? If that a is negative, is it going to be a happy face or a sad face? Sad face, negative, right? Because when you differentiate it, it'll still be negative. So the turning points, it'll cross the x-axis at the turning points, and it's going to be a sad face. Right, okay, so when you draw dy dx, right, okay, this is what it looks like. So remember, we're drawing dy dx. Okay, is that right? So if you start with a quadratic, dy dx will be a line. If you start with a cubic, dy dx will be a quadratic. Okay, and you won't be asked to start with anything else. Actually, you might be asked to start with a line. I'm just going to do that one now. Right, I have 30 seconds to do this. Right, do you know, this one's so basic you needn't bother even writing it down. Okay, but if I have a line x plus 2, if I differentiate that, I'll get dy dx is equal to what? Just 1. Agreed? The number in front of x. So when you have a line, you'll end up with just a parallel line. So you're drawing like basically y equals 1. Is that right? Don't even worry about that. Okay? That's it. So when you're drawing dy dx, you go down a level, right? And where at the turning points it crosses the x-axis. Okay? So that's all that section says. So do you know what? Let's do all of page 115. That'll do it. 3 to 6. I'll post it up in Teams, yeah. So all of page 115, so it's numbers 3 to 6. So page 115, 3 to 6.